Hello, ladies and gentlemen, and welcome to geometry. This will be your very first unit, so this would be your very first unit notes. So in geometry, we start off with the very simple basic building blocks of how we kind of construct everything in geometry. So we start off very simple. We start off with points, lines, and planes. And kind of why those three go together. These are what's known in geometry as the undefined terms. Okay, and I don't want to overly confuse you, but you need to understand kind of why they're considered undefined, and you do need to understand kind of how we work within them, even though they are undefined. Okay, so just kind of keep in mind that while we say that they're undefined, we can kind of use a working title, a working definition to kind of understand why we can still use them. Okay, so we're talking about points, lines, and planes. So when we do this, okay, so we use a description. We don't use an actual definition, okay, because a point is just a location in space, okay? It does not have shape. It does not have size. It's merely a location in space. Well, think about this for one moment. How, just for argument's sake, let's say, okay, I've got this distinct spot in space, okay, so we'll call it S. How would you define this exact point in space? And the answer is you can't. Okay, and that's true for so many things. That's true for so many locations. Now, there's world navigation tools, obviously. If you're flying a plane, if you're captaining a ship, then you've got, latitude, longitude, and there's ways to kind of give your location on the planet Earth. But when we get down to very finite and very small locations, you can't define that. Okay, and in order to define that, you would need other points to kind of help direct you towards that point. Okay, so that's why we call it an undefined term. So how do we name it? So for geometry, we use arbitrary points. Okay, we're just saying, hey, we have this location in space, okay? And it's arbitrary. We're not saying this specific defined space. We're just saying, hey, we have this point in space, this location in space. It does not have shape or size, but we name it by one letter. Okay, so if I just have an example, if I have that location, we'll call it P for point. Okay, that's all it is. So we talk about a point, and that is kind of it. A line is basically if you connect the dots with a whole bunch of points. There's no thickness, no width, so it just kind of goes on forever. So if I have a point here and a point here, I connect the dots, but a line keeps going. Okay, so it keeps going to the end of time. It keeps going forever in both directions. And I want you to pay special attention to this. There is exactly one line through any 2 points. All right, so that's a big statement. That's a big statement in geometry. There is exactly one line. Okay, so through any 2 points. So, and thankfully that is the case, because that would be very, very awkward. So if I had 2 points, but then I had like 2 different lines that went through that, okay, that would be complicated, because all that would do is really kind of confuse everybody. Okay, so that is very, very thankful that there's only exactly one line. So a line is named by 2 letters. Okay, and those 2 letters refer to points on the line. All right, so if I've got R and S, Okay, I would say RS, and I would draw it like this. Okay, this would be kind of the symbol for line RS. And I notice I put the two little arrows on there. That tells me that they're going to go on forever in both directions. Okay, so a plane, how does a plane change? So a plane is a flat surface, kind of a two-dimensional surface that extends indefinitely in all directions. And through any 3 points, there is exactly one plane. Okay, and those 3 points cannot be on the same line. So what you're looking at is, so just I have 3 points, A, B, C. Again, these are arbitrary points in space. And what they're saying is, okay, those 3 are not on the same line. You cannot draw one line between these 3 points. But through these 3 points, there is exactly one plane. And this is kind of how we draw a plane. Okay, so this is named by usually 3 letters. Okay, so this one would be considered like plane ABC. Notice again, not on the same line. Okay, if I put like a point here that is like on the same line as A and B, okay, I can't call that ADB, okay, because I don't know if I'm talking about the line or the plane. But it needs to be 3 points not on the same line. Okay, one note to make on this, sometimes it can be named by one cursive letter in the corner. Okay, so sometimes you'll see like a fancy script. So if I just say like plane P, so that would, if you see something like just in the corner somewhere, that's kind of naming the plane as well. But one of these 2 ways, so either 3 letters not on the same line, or if you have a letter that's usually in fancy script in the corner, that's an indicator that that's going to be the plane. So what I tell students, something that's a little bit easier to understand, imagine you had a piece of paper. Okay, so imagine you had a piece of paper, one piece of paper. Okay, but it's the thinnest piece of paper you've ever had, you've ever seen, and it goes off in every single direction forever. Okay, so you can't really hold it because it goes on forever. That's kind of the way to think about a plane. Okay? And again, it's undefined because, like, how would you name that? How would you define that? How would you explain that? It's not easy. A couple of terms to be familiar with. Okay, collinear. Collinear just simply means on the same line. Okay, and on the same line, and we are usually talking about points. Okay, so I would say something to the effect of A and B are collinear. Okay, I would just say something like that. A and B are collinear. That means A and B are on the same line. So collinear is a term you need to be familiar with. Now, coplanar, very similar. Coplanar just means on the same plane. Okay, so collinear, on the same line. Coplanar, on the same plane. Sometimes you will see kind of the opposite of that. Sometimes you'll see non-coplanar. Sometimes you will see non-collinear. That just means the opposite. So sometimes you'll see non-coplanar. That means not on the same plane. And coplanar, you could be talking about points or lines or a combination of. Okay, you can talk about, hey, these 3 points are coplanar, or this point and this line is coplanar. Okay, you could be talking about points or lines. And an intersection is just exactly what you think of. As you guys start to take driver's ed, intersections have a number of rules for driving. So an intersection is just where lines or planes meet. Okay, so if you consider down here, so here we have a line L and a line M. Okay, and this is another way you can name a line. Okay, you can just name it with kind of a cursive letter, and they meet at point P. Okay, so two lines, when they intersect, okay, they make a point. Okay, if you think something like the exact middle of the intersection of a road, that's kind of what you make. So they intersect at a point. Two planes, and if you notice, you have kind of the script, the cursive letters there. That's telling you that I've got plane A and plane B, and when they intersect, they actually form a line. Okay, so you can kind of indicate that there. I know this is very, very particular, very, very detailed, but it's good to think about. So if we consider what geometric term, so I'm looking at the floor here. And floor, the closest thing that would be a plane. Okay, that would be a two-dimensional object that goes on forever, except floors don't go on forever. Okay, so that would be considered a plane. Okay, so the radio tower, if we consider that this would keep going, you could argue that would be a line. Okay, if we consider that it could go in both directions forever and ever, then you could argue that it could be a line. Not a great example, but there are very few examples of what a good line would be. This last one, pushpin, I'm talking about the very, very end of the pushpin right here. So that's going to obviously be a point. All right, and these are just examples of what you would be looking at, of what you could be looking at, what you can compare it to, okay? So if we consider this, so now let's take a look at what we got here. So we have a plane, okay? This plane is named B. We've got several points, okay? J, K, and L are all on the same line, and that line is called A. Or at least one name for that line is called A. You can name it other things. Then you have point M, which is not collinear with J, K, and L, but it is coplanar. Okay, so what do they want? They want to know, name a line containing point K. What is another way? So point K, right here, what is a line containing point K? Well, I can literally just say line A. That would be enough. That would be all I would need to say. I could also say line JK, JL, any combination of the two collinear points would be acceptable there. Okay, so name a plane containing point L. So the point L is on this plane B. So I could literally just write plane B. That would be enough. Another way would be 3 non-collinear points So another way I could say that would be, plane MJK or MKL. Okay, any of those would work. Okay, notice though, like when I do this, JK is on the same line. Those two are collinear, but M is not. That's fine. I can still do that. Okay, KL, those two are on the same plane. That's fine, but M is not with them. So I'm perfectly okay there. So here, name 3 collinear points. So remember, collinear, same line. So if I consider this, take a look. So if I'm looking, I see A, I see B, I see D. Those are all on this line. So I can say A, B, and D. Those are the only 3 that would work. A and C, B and C, those would be collinear, but they want 3. That's only the A and B and C and A and C, it's only 2. So our points A, B, C, and D coplanar. Well, let's look. So B and C are definitely coplanar. A seems to be up here, D is down here, so I'm going to say no. Identify the planes in this picture. Well, there's obviously plane K. And then it's kind of hard to notice, but if you look, and the picture kind of makes it a little weird, there's also a plane for the triangle ABC, for this shape right here, ABC. Okay, so I would also argue you could say plane ABC. Again, ABC, those are non-collinear. They're not on the same line. Okay, so I can do that. I can name it that way. So what is the intersection of BD and AC? So where do these two cross? Where do these two intersect? Those intersect at point A. So part letter B, K. So we're talking about the plane K and AD. So AD is this line right here. So this line is not on the plane, but it goes through the plane. And point B is kind of your spot there. It kind of goes through, but it's not on. So I would argue that that's going to be point B. Okay, and then this last one, K and M. Well, if you notice, that line is on the plane, okay? So the entire line intersects with the plane. So if the entire line intersects with the plane, I'm just going to say line M. The entire line is on the plane, so the entire line intersects with the plane. So now we get to draw a little bit. So let's draw. So line N intersects plane P at point I. Okay, so we have a line. It intersects a plane at point I. So if it intersects the plane at one point, then it's not going to be on the plane. Okay, so I have this plane, and we call it plane P, and we have this point I, and line N intersects plane P there. Okay, so from here I would draw something like that. And that's going to be line N. That would be a good example of that. Okay? Okay, so B and Y are coplanar in plane Q, but do not intersect. Line N intersects line B at point C and line Y at point D. Okay, so wow, a lot of things going on. So we have line. Let's start with here. So we have plane Q. So let's see how we can kind of satisfy all these conditions. So we have plane Q. We have a line B and line Y, but they do not touch. They do not intersect. But they're on the plane. Okay, they're on the plane. They're in the plane. Okay, so we've got this part checked off. Okay, line B and Y are coplanar in plane Q, but do not intersect. We got that covered. Okay, so line X intersects line B at point C and line Y at point D. Okay, so line X, so this thing here, it's going to cut in to both of them. Okay, it's going to intersect with both of these lines. And then it's going to intersect at the specific points. Okay, so if I have line X, it looks something like that. I'm going to call that C. I'm going to call that D. So let's just make sure I got it. So line B and Y are coplanar in plane Q. So B and Y are coplanar. They do not intersect. Line X intersects line B at point C. We've got that. Line Y at point D. We've got that. Okay, so we're done. Okay, so R and B intersect at line XY. Okay, so what does that mean? So you've got two just letters, but there's no, but there's no, they're not points. They didn't say point R and point B. It didn't say anything like that. But it's italicized. It's almost like trying to be cursive. So these two are talking about planes. Okay, and they intersect at a line. So what does that mean? So that means I need to draw a plane. Okay, we'll call this plane R. And another one that's going to intersect it. So I'm going to draw something like this. All right, so I've got this line right here. So those two planes intersect, and I'm going to call this point X and call this point Y. So that would be two planes that intersect at XY. Okay, that satisfies that one. Okay, so now you go attempt the 1-1 assignment. Okay, so you're going to have to do some drawing, you're going to have to do some thinking, you're going to have to do some spatial reasoning, and then once you're done, okay, go into quizzes and put in your answers and make sure that you get 100%. Okay, thank you, and we'll talk to you next time.